Assalamualaikum and hi guys. In this video you will learn on how to solve method of undetermined coefficient for the case 4, whereby case 4 is a linear combination for the case 1, case 2 and case 3. Case 1 is whereby your fx is equal to the polynomial function, case 2 for the exponential function, and case 3 for the trigonometric function involving cos and sine. So let us try to write the solution for the yp if our fx is equal to 6x minus 9 plus 5 sine 4x. So 6x minus 9 is considered for the first function f1x, whereby this one for the case 1. 5 sine 4x is considered for the second function, whereby f2x is equal to 5 sine 4x. So this is from case 3. So you have to write your yp according to your case. So means that your f1x is from case 1. So you have to write your yp according to the case 1. So fx is equal to 6x minus 9. So therefore our yp1 is equal to cx plus d. Okay, so you have to refer to the highest power of x here. We have x the power of 1. So that's why our yp1 is equal to cx plus d. So f1x means that your yp is for the yp1. So f2x means that you have to write for the yp2. So yp2 is according to the case 3, whereby you have 5 sine 4x. So yp2 will become c cos 4x plus d sine 4x. Okay, so that is how you have to write your yp according to your case. So let us refer for the second example. So our fx is equal to 2 minus 3 exponent 4x. So you have 2 here for the polynomial function from case 1. You have negative 3 exponent 4x is from case 2, whereby you have exponential function. So f1x for the 2. f1x is equal to 2. f2x is equal to negative 3 exponent 4x. So f1x is from case 1, whereby you have a polynomial function. So this one for the case 1. f2x for the exponential function. So this one from case 2. So now you have to write your yp1 according to the polynomial function. You have 2 here. So yp1 is equal to c. yp2 according to the exponential function, you have negative 3 exponent 4x. So yp2 will become c exponent 4x. So let us try to solve this example. By using method of undetermined coefficient, solve the following differential equation. So you are given y double prime plus y prime minus 2y is equal to 2x minus 40 cos 2x. So on your right hand side, you have 2x minus 40 cos 2x. 2x here is from case 1. And negative 40 cos 2x, this one is from case 3. Solution of non-homo is y is equal to yh plus yp. But now, your yp here is come from 2 cases, whereby you have case 1 and case 3. So therefore, yp is equal to yp1 plus yp2. So you have to solve for yp1 and then you have to solve for the yp2 according to what case that you have. Okay, so for this question, the first one you have to find the solution for the yh. So find yh by solve left hand side. So make it equal to 0 and then you have to solve for the homogeneous equation. M square plus m minus 2 is equal to 0. And then by using calculator, your m will become m1 is equal to 1 and m2 is equal to negative 2. So we have a different roots here. So therefore, the solution for the yh is equal to a exponent x plus b exponent negative 2x. So this is our solution for the YH. Okay, now you have to solve for the YP. In order to solve for the YP, you have to solve for the YP1 and then you have to solve for the YP2. For the YP1, you have to solve according to the case 1 whereby your fx is equal to 2x. So f1x is equal to 2x. f2x is equal to negative 40 cos 2x. Make it in a table so that it's easy for you to refer what is your YP1 and what is your YP2. So for the f1x, you have to write your YP1 according to the polynomial function. So therefore YP1 is equal to Cx plus D, because the highest power of x is x the power of 1. So from YP1 here, you have to compare to the YH. So this is our YH. A exponent x plus b exponent 2x. By comparing YH with the YP1, there is no equal term. Means that our YP1 is suitable for the next step. So make it a star here so that you know this is the suitable YP for the next step. So from YP1 here, you have to find YP1 prime and YP1 double prime. So differentiate Cx plus D will become C. Differentiate C will become 0. So from here, you have to substitute back into the original question in order to find what is the value for the C and D. So from this original question, your right hand side you have 2x minus 40 cos 2x. But when you are solving for the YP1, you only have to solve for the y double prime plus y prime minus 2y is equal to 2x. Because the negative 40 cos 2x, this one for the YP2. So you have to solve for the f1x only. So therefore, y double prime will become 0 plus y prime will become c minus 2y, 2 multiply with cx plus d is equal to 2x. Okay, so you have to expand the left hand side. C minus 2cx minus 2d is equal to 2x. So by comparing the coefficient for the left hand side, you have x the power of 1 and x the power of 0. For the x the power of 1, you have negative 2c is equal to 2. So therefore c is equal to negative 1. For the x the power of 0, we have c minus 2d. c minus 2d is equal to 0 because you don't have anything x the power of 0 on the right hand side. So since we already have the value of c, you can substitute the value of c to the equation c minus 2d. Negative 1 minus 2d is equal to 0. So therefore d is equal to negative 1 over 2. So substitute the value of C and D to the YP star that you have right before this, whereby YP star is equal to CX plus D. So therefore, YP1 is equal to CX plus D. Substitute your C equal to negative 1. So YP1 will become negative X minus 1 over 2. So this is the solution for the YP1. So now continue to find the solution for the YP2 for the f2x equal to negative 40 cos 2x. So YP2, you have to write your solution for the YP2 according to the case 3. So this one will become C cos 2x plus D sin 2x. So from YP2 here, you have to compare to the solution for the YH that you have obtained before this. So by comparing YH and YP2, there is no equal term because YH in terms of exponential and YP2 in terms of trigonometric function. So means that YP2 is suitable for the next step. So make it a star here. So from YP2 star, you have to differentiate in order to find the yp2 prime and yp2 double prime. So differentiate c cos 2x, differentiate cos will become negative sine. So negative 2c sine 2x. Why you have negative 2 at the front here? Because we differentiate the argument to x become 2. Differentiate d sine 2x, differentiate sine will become cos. So this one will become 2d cos 2x. So continue differentiate for the yp2 double prime. Negative 2c sine 2x, differentiate this one will become negative 4c cos 2x minus 4d sine 2x. So the same step, you have to substitute the whole thing to the original question in order to find what is the value for the constant c and d. Y double prime will become negative 4c cos 2x minus 4d sine 2x plus y prime will become yp2 prime. So substitute negative 2c sine 2x plus 2d cos 2x minus 2y. So substitute minus 2yp2 minus 2 multiply yp2 c cos 2x equal to, so this one you have to make it equal to negative 40 cos 2x. So now you have to expand the left hand side. Negative 2 multiply c, negative 2 multiply d. So negative 2 multiply c will become negative 2c, negative 2 multiply d will become negative 2d. So now by comparing the coefficient, on the left hand side we have the cos 2x and sine 2x. For the cos 2x, on the left hand side we have negative 4c plus 2d minus 2c equal to, on the right hand side we have cos for the negative 40. So simplify because you have negative 4c minus 2c. So negative 6c plus 2d is equal to negative 40. So this is our first equation. By comparing for the sine 2x, we have negative 4d minus 2c minus 2d is equal to, on the right hand side you don't have anything for the sine 2x, so this is equal to 0. So for first equation, you arrange c at the front, so means that for the second equation you also have to arrange c at the front. So negative 2c minus 6d is equal to 0. So this is our second equation. So in order to solve equation 1 and equation 2, you have to solve by using calculator. So calculator will give you the answer for c is equal to 6 and d is equal to negative 2. So substitute back this value to the position of yp2 star. So your yp2 is equal to c cos 2x plus d sine 2x. So therefore yp2 is equal to, your c will become 6 cos 2x plus d, our d is equal to negative 2 sine 2x. So this is the solution for the yp2. So therefore the solution for the yp is the yp1 plus yp2. So therefore yp is equal to yp1 negative x minus 1 over 2 plus 6 cos 2x minus 2 sine 2x. So this is the solution for the yp. So therefore the general solution is y is equal to yh plus yp. So you have to combine back your yh plus with the yp. So this is the general solution for this non-homogeneous equation, whereby this is the yh and the whole thing here is our yp.